Hello everyone, I'm Jeon. I'm researcher at a university in South Korea. In this presentation, I'm going to talk about ChamberBreaker, mitigating echo chamber effect and supporting information hygiene through the Gamified inoculation system. This work is done with Bogoan Kim, Dr. Aiping Xiong, and Dr. DONGWON Lee, and Dr. Youngseung. When individuals feel comfortable sharing their emotions, respecting others' views, and interacting, they tended to believe they are in the safe space. People think that social networking service SNS could be a safe place, which provide diverse perspectives. However, contrary to the expectation, SNS may limit users to only like-minded information and make them only interact with peers with similar thoughts. This can generate an echo chamber effect. In an echo chamber, the user have individual's tendency to favor consonant and avoid dissonant information, hence accelerating the dissemination of fake news or causing political polarization. There are several attempts to help participants recognize their bias status. However, there is no attempt to help become fully aware of the negative effect on echo chamber. In this work, we present ChamberBreaker, CB, a game-based system designed to help increases one's awareness of and response to echo chamber effect based on three theories. First, we use inoculation theory as a main approach of CB to mitigate the echo chamber effect. Second, use a heuristic for judging as a story of the CB, and use a gamification as a rule of CB. The psychological concept of inoculation is based on a biological metaphor. According to this concept, injecting a weakened dose of virus into the body creates an antigen. The antigen produces antibodies that create an immune response and resist the future infections. If this mechanism is applied to an echo chamber, the inoculation of information can be achieved by creating mental antibodies against the echo chamber effect. This is the process of ChamberBreaker. A player becomes anonymous SNS user John Doe, who is a member of the SNS community. As John Doe, the player has a responsibility to help solidify the echo chamber phenomena in communities. The player proceeds with three scenarios in the randomized order. Each scenario describes the characteristics of echo chamber effect. The player is first asked to choose tweets with echo chamber characteristics, which are then shared with community members. After sharing a tweet, the player can see the responses from the other community members. Then the higher score means a higher possibility of community members falling into the echo chamber effect. If the player achieves the higher echo chamber score, the player will see negative consequences of the echo chamber effect in communities. Each of the three scenarios focuses on one specific characteristic of the echo chamber effect, such as social boundary, user similarity, and information homogeneity. Before each scenario starts, the player will see the explanation of each characteristic of echo chamber and relate to it, and learn about each characteristic. In each scenario, a total of the 6 tweets are separated into the two groups based on the strength of echo chamber effect. One is the strong tweet group, the other one is the weak tweet group. If a strong tweet is chosen, the player can get a higher score. For each scenario, the player can have 5 attempts at most. In CB, there are 2 score gauges, the echo chamber gauge and reliability gauge, which are opposite concepts. The design rationale for having 2 scores is that increasing only echo chamber score would be unrealistic. If someone intentionally shares a particular tweet to make an echo chamber, community members are likely to think of the behavior as suspicious. For this reason, we set up the task of requiring participants to increase echo chamber score while keeping the reliability score above a certain threshold. After completing each scenario, the player will see how the propagation of fake news is accelerated by the particular echo chamber. To examine the effectiveness of the ChamberBreaker, we conducted a user study. we recruit a total of 882 participants on Amazon Mechanic Turk. We had a 2-user group for the study. In the experimental group, the 436 participants were asked to complete the pre-survey, play CB for about 15 minutes, and complete the post-survey. In the control group, 446 participants were also asked to complete the pre- and post-survey, but instead of playing CB, they were asked to read the explanation of the echo chamber and an example of the scenarios and tweet using CB. We use 2 metrics in the pre- and post-surveys. First, we use an EC breaking score. The EC breaking questions are based on the 5 features of the echo chamber effect. In the pre-survey, we ask about the participant current behaviors, and in the post-survey, we ask about their willingness to adopt the behaviors that could prevent the echo chamber phenomenon. Second, we use a reliability score. The 6 news items and corresponding tweets are used to measure the reliability score. The news item covered 3 characteristics of echo chamber and 3 domains. Now, I would like to present study results. We found a significant difference between the pre- and post surveys in the experimental and control groups. In EC breaking score, only the experimental group showed a significant difference between the pre- and post surveys. The significant increase in the EC breaking scores in the experimental group indicate that CB could help participants to realize the importance of a diverse perspective when consuming information. Also, in reliability scores, only experimental group showed significant difference between the pre- and post surveys. This result showed the effectiveness of CB in increasing a player awareness of echo chamber effect, yet this occurred regardless of the veracity of the news information. We further measured whether the score of the experimental group were influenced by demographical factors. As a result, we found the age and political stance showed some impact. First, in the case of the EC breaking score, we identified significant difference in the score among the age group between the pre- and post surveys. The Posthoc analysis showed that the difference was evident for the 30 age group and for the over 50 age group. In addition, we identified the significant difference in the score among the political stance group between the pre- and post survey. The Posthoc analysis showed the moderate and liberal group showed significant differences. Next, in the case of the reliability score, we also identified significant difference in the score among the age group between the pre- and post survey. The Posthoc analysis showed that difference was evident for over 50 age groups. In addition, we identified significant difference in the score among the political stance group between the pre- and post surveys. The Posthoc analysis showed that the liberal groups showed significant differences. We also found a significant difference in the playing times according to the age group. This result showed the possibility that the significantly longer playing times for the participant in the over 50 age groups could have influenced the gap between the pre- and post surveys. In this work, we suggested a theory-driven methodology for system design that can help increase one's awareness of and preemptively respond to an echo chamber effect. In addition, we demonstrated the feasibility of our methodology based on the result of the user study. Furthermore, our study results imply a possibility of expanding our method to digital literacy education. This refers to helping use consumer correct interpret news through the critical thinking and have a good information hygiene. Lastly, we confirmed the importance of playing time in developing an interface and suggested the necessity of additional relevant study as a future work. This study could indicate the interface design to help people to spend proper time for judging the veracity of information. If you are interested and want more information, please refer to our paper. Thank you very much.